My name is Schaeffer Summers. I'm an assistant professor at the University of Virginia with a dual appointment in the Schools of Architecture and Medicine. In medicine, I teach a course in the Department of Public Health Sciences that explores the intersection of the built environment and public health. In architecture, I teach design studios and an interdisciplinary research seminar called Design Logics, which is the course I'm introducing in this presentation. My background is in aerospace engineering, which informs how I approach research and teaching in the disciplines of architecture and public health. As an engineering student, I was required to show my work in solving problems, and it's this approach that drives my interest in evidence-based practice and design. My recent work exploring relationships between humans and environments can be traced back to my role in the U.S. Space Station program at Johnson Space Center, analyzing crew training requirements for the airlock and EVA systems. One of the differences between the engineering and architectural education is that a building design can stand on its own as an aesthetic and functional response to a problem. We can critique architectural projects without necessarily knowing the incremental steps and logics taken in the process of design. However, the built project can lead to unintended consequences, which can be both positive and negative. The Pruedigo housing project in St. Louis is a case study in the discrepancy between the architect's intentions, the larger architectural discourse of the time, and how the environment eventually shaped the behaviors and lives of its residents. In order to improve the public health outcomes of our work in a significant way, it's necessary to gain a greater understanding of the potential health impacts of our decisions as we're designing and planning the built environment. This course offers a transdisciplinary framework for conceptualizing and evaluating programs and projects to better understand these health impacts using a tool called a logic model. The logic model is a cornerstone of program planning and evaluation, a systematic method for collecting, analyzing, and using data to examine the effectiveness of a specific program and to understand why it may or may not be working as planned. A logic model is a form of tree diagram that represents how a program can lead to a series of outcomes over time. The initial input of a logic model is the entire project or a component of the project. This input generates a series of immediate outputs. Those outputs become new inputs that generate intermediate impacts and so on, until more distal health outcomes are revealed. The model represents a theory of change, how the system will develop and perform over time. One way the logic model has been used in the planning of the built environment is through a methodology called Health Impact Assessment, or HIA. There's already an established practice within the discipline of urban planning using HIA to inform transportation, zoning, and other large-scale development projects. I had a grant from the Robert Wood Johnson Foundation and Pew Charitable Trust to conduct an HIA to assess the work of an Enterprise Rose Fellow working with the Santo Domingo Pueblo in New Mexico. This is the logic model I researched to trace the impacts of rehabilitating adobe homes in the Pueblo village. One of the logical pathways that I've found is that the rehabilitation of adobe contributes to the preservation of traditional construction knowledge and Pueblo culture, which can lead to an increase in social cohesion and mental health in the community. The model also indicates that there are potentially negative health outcomes resulting from the displacement of residents during construction to temporary housing located outside the village center. In this course, we will critically examine both the stated intentions of a project as well as the unintended impacts and the consequences of the work in the built environment. We will explore ways to go beyond evaluation to integrate logic modeling in a collaborative research process that can play a generative role in architectural design and urban planning. Architecture is fundamentally a visual culture, and it's important to develop methods of representation to communicate and translate scientific knowledge into a form that can be understood and assimilated into the design process. This is the work of the student Zhuting Zhen, visualizing research in attention restoration theory in my research seminar last fall. The study compared exposures through window views, as well as simulated nature to understand the response of a student population. The study found that two-dimensional views of nature can produce a restorative response, and that landscape views of water create the highest levels of attention restoration. This is one example of the type of research finding that might spark an idea that will inform your design. The logic model can provide another way of abstracting and representing findings from scientific studies, complementing conventional architectural drawing methods. This diagram traces the physiological responses of patients exposed to a two-dimensional image of a nature in a stressful healthcare environment. In the course, we'll review and visualize scientific literature as the building blocks from which to construct a theoretical framework for architectural programming and planning. The course will also draw on historical research that connects the modern movement in urban design and architecture to the need to create healthy environments. We'll look at the work and writings of Florence Nightingale, Le Corbusier, Schindler, Aalto, and other architects and designers to understand their design intentions and the health impacts of their built work through the lens of environmental psychology and neurourbanism. Case study analysis will provide an opportunity to examine projects such as the urban landscapes of the Seagram Building Plaza and Paley Park in New York City. Projects like these give us an opportunity to unpack complex environments to define the range of social and environmental relationships that are possible. Students will have the opportunity to select a precedent to analyze that will assist them in the development of a final project in the course. For example, you might compare and contrast Florence Nightingale's Notes on Nursing with the Butaro District Hospital by Mass Design. Students will conduct a systematic literature review and develop a comprehensive logic model for a project that they are developing in another course or in preparation for a thesis studio. In this example, a logic model for the program identifies the health impacts and co-benefits of an intergenerational community center for seniors and youth. In my research, I found that senior citizens will experience a reduction in social isolation and loneliness that will improve their mental health and reduce their risk of disability. Youth will also benefit from knowledge sharing, critical thinking, and non-cognitive emotional skills, which will increase their empathy, respect for elders, and educational outcomes. The renderings of recreational spaces and garden courtyards test ways to reduce stress in clinical settings based on stress reduction theory. The course will test the proposition that logic models can be used to generate as well as evaluate architectural programming and design. The COVID-19 virus has exposed the urgent need for evidence-based practice at all levels of society. As we grapple with the impact of the pandemic, designers and planners will need new skills in searching for, understanding, and critically reviewing evidence that we're considering as the basis for design and policy. The process of synthesizing the causal health pathways in the logic model becomes a vehicle for transdisciplinary work, since the work quickly requires the researcher to cross the boundaries of multiple disciplines and fields of study and synthesize new understandings and relationships. Students will come from the class equipped with the research skills necessary to participate in health impact assessments, as well as integrated design processes that contribute to enterprise green communities and the USGBC LEED credit for health promotion. I recently presented the design logics approach at the conference of the Association of Collegiate Schools of Architecture, and you can access the paper and presentation video in a UVA box folder by following the link on this page. Thank you for listening. If you have any questions about the course, please reach out to me. I welcome your feedback, and I'm happy to set up a time to meet and talk about your thesis or other interests in design and health.